So this is the book for limestone. This will be if you're studying triple science in year 10. So again, you get a nice knowledge organizer that you can use and look at. You will have had this in class, but again, you can pause the video and just look at it in a little bit more detail. There's not loads of things that you can kind of ask on the limestone cycle. Again, some keywords that you can stop, have a look at, think about, anything that you might understand they're key to this topic. Like always, just ignore that at the top because I've changed that. The questions get progressively harder. You can pause. I'm not going to kind of explain them all. This is because you get a solid and you kind of get a liquid version of it, or what we'd really call aqueous version. That's why they're both the same thing. Observations are really important. And again, the questions do get progressively harder or progressively more descriptive, but please pause the video when you think you need. The same as this. Nice kind of review sheet, all about the key topics. Like I said, there's not a lot to know. The most difficult bit is definitely the thermal decomposition bit, and knowing that the more reactive, so the ones at the top of the reactivity series are going to give more stable carbonate, so they'll take longer to break down. But again, please pause, have a look at what kind of things you would need. With the limestone actual cycle, you need to know names and chemical formulas, and sometimes they ask you for common names as well. So just be aware that that could be a question I'm sure you've looked at in class or will look at in class, but just for you to be thinking about. This kind of question does come up quite a lot, the 6 marker or the extended writing or whatever we're kind of calling it at the moment, looking at different ways that we can quarry. Now this one's actually giving you some pictures, and it's also explained like how we get the quarry to work, so there's a bit more of help. So I've broken it down. Remember, as long as you're writing in cohesive, even bullet points is fine. So I've put negatives. Loud explosions could damage habitats. It could also cause dust pollution. Heavy machinery could cause noise pollution. Using diesel fuel could also give us CO2, can contribute to global warming. Positives: limestone and cement production can create jobs. We can create buildings. Areas near quarry will also see a workforce spend. They might even live in the area. So if you live close and there's a Tesco or something nearby, they'll see an increase in the amount of people. So they'll see an increase in spending if they're near a quarry. This, like I said, these are the common names of the different parts of the limestone cycle. So state how limestone is converted to quicklime. That's thermal decomposition, heating. State what happens to the quicklime in order to make slackline. You add water. Further add water if you want to make lime water. Give the correct formula. So limestone is that one, quicklime is that one, and then slackline. And again, they're common names. So that's calcium carbonate, calcium oxide, calcium hydroxide. Give a use for limestone: buildings, making cement. They're your big ones you need to remember. A little bit of maths now, quite a nice easy math. At the start, you've got 2.5 grams of calcium carbonate. 1.4 grams of the solid remained after heating, so take that away. So you've got 1.1 grams of the carbon dioxide. So it's always cannot be created or destroyed. So you've got 2.5 here. It means these need to add up to 2.5. Suggest what could be done to confirm that decomposition was complete. No more CO2 is produced. Bubble through acid. If CO2 is present, CO2 is produced and the calcium carbonate is still present. Nice little bit of a limestone cycle, but obviously remember you can go back up here. Write a balanced symbol equation for the reaction in 2. So I've spoken about how this is calcium oxide. You need to know their names. Plus water will give you slacked lime. Which stage is extremely exothermic? Stage 2. Demonstrates thermal decomposition is stage 1. Describe a simple test. So CO2 is present, it will turn lime water cloudy. Again, another question about quarrying. In your opinion, do the advantages or disadvantages outweigh it? Yes, it creates jobs, brings money to the area, makes limestone to sell for other resources. So I do think it is an important way to get limestone, but you could have gone in completely the opposite direction and done a disadvantage. That's fine, as long as you've given a really good opinion there. Then, strangely, there's a little bit of maths to be added, or numeracy to be added to this one. It's called relative atomic mass. They will give you the equation. They will give you the equation. So just keep thinking of that. And if you notice with this one, they do the mass number, the massive number, times by the percentage. And you could have, like this one's got 4, that's fine, okay? They're not always going to add up to 100, okay? This one just adds up to 100, but your percentages might be off. Normally they're 100, but if you get a percentage that's slightly off, that might be that something else has been made in the reaction. But if you need me to go through any of these or the answers I've got for any of these in a little bit more detail, just drop me an email. And then the last little bit is enzymes. This is more studied in the biology topics, but it does come up a little bit in the limestone topic. So enzymes are biological catalysts. What's their function? They break down large molecules into smaller, more useful molecules. You need to know that definition. Identify all the fruits that contain protease. So protease is an enzyme that breaks down proteins. In the investigation, some students use gelatin protein to identify which fruits contain protease. So you're looking for fruits that get broken down. So it's going to be kiwis, figs and pineapples, because they didn't turn into a solid. Explain the conclusion. Liquid at the end, protease broken down protein, so cannot set. Student commented the results of the protein are not valid. Peaches are boiled. Enzymes would have been denatured. State how you could attain valid results. Use fresh peaches. Suggest a temperature at which the gelatin should be kept before pouring into the test tubes. 20. It's around room temperature. You notice how these variable questions come up quite a lot. So another variable, another control variable. The mass of the fruit is must be a big one. Kind of temperature that you're using as well. Mass of the enzyme would be a good one. So there's lots of different things you could have written there.